I'll do my usual thing that, that I gauge the interest of the audience, and I see that, over half of the people who are here have already heard me talk about this, right? So what that tells me is that there is a reason we do not excel in what we try to do, because you are here trying to pick up a bag and waste your time. I told people that don't come. I've already talked to you about this, but they still showed up. So, so I do plan to waste your next hour by talking about things. And in general, when Ramesh said that I was having a midlife crisis, and I said I have 3 kids, I need a food. I want to buy a food car. So they said, sure, go ahead and do it. You think we can do it? And my where I'm starting this is that I don't think Oak Ridge National Lab is in a position to compete in this big data business. Making that claim right in front of you. Okay. I'm going to walk you through examples of what I think is going on out there, and that's the challenge that we are trying to go after with this institute, is that can we be recognized, or can we get there in terms of what people think is doing great stuff for future science. So I'll talk a little bit about, I have to talk about geography because that's what I do for a living now, and then give you examples of what it is. But it's mostly other people's work. Okay? But things that keeps me thinking about what is this whole thing all about, and what we can do, and where we can fit it. And most of the pictures, as I said, are shameless story. There are some chairs in front. We will not tell you that we sat on a handicap chair. So I always make this claim when it comes to data, is that data is mostly geographic. I have this is my favorite slide that I keep showing it for, and I've been showing it for the last 7 years, is that census is known as the mother of all databases. Okay? 1790 is when the nation did its first census, and 3.9 million people were counted. 1810 to 1850, we were the usual self of being curious. We wanted to know all kinds of things about, people like, are they poor, rich, what kind of religion do they practice? So the challenge came in 1890 when estimated 65 million people were going to be counted, and they realized that if the Marshalls Sorry about that. That shows how loud I am. Nobody complained. The challenge was that 65 million people were estimated to be counted, and if the Marshalls went down on horsebacks, they would have never finished the process in 10 years. So what do? So necessity is the mother of invention. So people went out and found this biostatistician in Baltimore who had this technology of counting very fast, which was the punch card. And that was commercialized and formed this company called TMC. And interestingly, between 1911 and 1924, through 2 or 3 mergers, it formed IBM. So that's what I claim as geographic data driving innovation, right? Including computing. So let's fast forward. We are about GIS. What you guys all know about. There's lots of data associated with it. 63 is when Roger Tomlinson first uses the phrase GIS. 69 is when first commercial companies start coming in, and then NASA Earth observation satellites. And 85 is one of the tipping points in our civilization when we got into GPS. If you take GPS out of the equation in today's life, we will be obsolete. Okay? It's that integrated. 2001 is when Keyhole Corporation comes up with this 3D web viewing technology, and then Google buys it in 2004 and turns the World Wide Web into the Web Wide World. So now you can use your browser, go anywhere, look at anything, right? So the question is, what is next? What are we trying to do, right? It seems like we want to, but in reality what we are trying to do is I'm paraphrasing it, is that we want to know everything about everything at all times except us. We don't want to be part of that system. Okay? But you guys all are fair game. So a couple of weeks back, I think this is what I thought was, what is that next thing? And you may have already seen this. This is 1080p HD video coming from space. A private company sent birds out, these microsatellites, and they're sending 1080p HD video. Okay? It's worth watching it for a minute. Okay? I think it's fascinating. You think about what we are trying to do with observations. I think this is incredibly fascinating. And this is just the beginning, right? It's just going to change the way we have always looked at our environment. It's just mind-boggling. And this is not even government. This is private sector. Okay? This is 2 companies who have sent about 30 microsatellites each. They will cover the world as 3-meter resolution data in 1 year and flood the market with more data than you can ever imagine. All right, so you can go and search for Skybox and look at it, because I need to get back to this wonderful thing. So one thing is, all right, so big data, if you go out and search on the web, what I find is the big data is the battle of the V's. Okay? And as a layperson, I try to understand what those battle of the V's are. So, I found these kind of explanation of what big data is all about, structured, unstructured, sensor, new type of data, and volume, velocity, and variability, right? That's the 3 V's, big data supply chain. And then I found Oracle coming up with a 4th V that says volume, velocity, variety, and then value. So, how much trust do I have in these different kinds of data? So there's a lot coming at you fast, very rapidly, lots of different types, and then value. And, people are trying to be creative, data at rest, like archives, data in motion, streaming, data in many forms, social media, and then data in doubt, which is that value proposition thing, right? But this one, I'm just completely baffled with this image. I have no idea. Viscosity. It looks like I'm in high school physics class, right? Variety, velocity, virality. So it's a mind-boggling thing. I have no idea what those things are. What is virality? That big data spreads fast, goes out into this network. That's kind of interesting. So, maybe, it's time for the 6th V to come pretty soon. But if you let aside those debates, there are few fundamental things we are trying to do with this big data. How big is one question that everybody asks. And the simplest answer is, whatever you cannot handle today is big for you. It's as simple as that. It can be megabytes, gigabytes. It doesn't have to be that big. I always tell people that giving one of these presentations is a big data challenge for me, because they said, you have 7 days to prepare for 45 minutes, and I look at 500 slides. So I'm trying to pick 45 out of 500 in X amount of time, like I was doing last night. But one thing is, we are always curious about, can I predict behaviors of systems? So I want to have some predictive capability, or I want to explain what I observe. Is there a way I can explain things that I am observing? But at the end of the day, the community, whether it's science, whether it's business, whether it's operations, they are very value conscious, right? Why should I care about big data? What is my return on investment? So the 3 things that I have been able to find is that, one, you have to go and tell them that, look, what I'm going to get you out of this big data business is a very novel insight that you did not know before. Okay? This is novel, new scientific insights, or whatever that might be. Or what it sells even better, that I'm going to give you that answer that is you are already getting, but I'm going to give you much quicker and faster, which eventually translates into saving of time and money. And then the other appeal is that I will impact from the individual level all the way to enterprise. So it's not just like the bank will win, but every customer is going to win, and I will know that I'm getting a benefit. Okay? That's the other thing that we do not have today. I will tell you that more data doesn't make the answer better. Okay? You can pump as much data as you want into your model, and you will see that at one point of time, the answer is not getting any better. And we have all done science, and so we know that. Big data should enable both big and small science. So as I said, going back to the individual scale. And as a national lab, I think our primary responsibility is to figure out not how somebody might find a cab quicker on the streets of Washington, D.C., but how can I turn this world into the mission we support, whether it's DOE or any other federal agency, right? How do I make this part of governance? And I'll get into some of that examples in a minute. So let's come back to urban and humans and this big data issue. And again, you have heard me say this, that if you think congestion, emissions, and climate are pressing problems for the society, the simplest and elegant use is that we all stay home. If we all stayed home, you will not have congestion, you will have very less pollution, and you will make significant impact on the surroundings. But we don't want to do that. And that's where the one key thing is, that why, as human beings, we are so curious that we refuse to stay put. Okay? If you think about internet and communication technologies, ICT, the common belief instinct is that, we have Skype and we have FaceTime and we have Hangouts and all this stuff. So people may not want to, we work from home. We may not need to travel anymore. If you look at the research, what it will show is that over the last 10, 15 years, with the growth of ICT, travel has only gone up because we are curiosity driven. If we see something, we want to be there. Okay? I'll give you another example. When Silicon Valley heavily promoted work from home, people thought that now the traffic congestion is going to get a little better because people are working from home. It did. But you know what happened? The emission was much higher because now people realize that they can live farther out and not have to commute every day. So they, instead of driving 50 miles a week, now they are driving only 2 days out of the 5, but they are driving 150 miles. And it was an interesting thing that they found out. But let's look at our society. We are trying to merge networks. We are trying to take the energy network, which is, you can think about electricity. We are trying to take the transportation network and trying to merge them with the help of cyber and communication networks. Okay, so it's a thing of merged networks. And we are in the central piece of that. What we decide to do as individuals eventually culminates into these bigger systems issue, right? But the bottom line is, anything that we do in the future, we will not compromise. We are very unlikely to compromise on our energy, environment, and mobility interests. We have to satisfy all those three in some ways. So big cities have a lot of people, there are a lot of moving parts, there's a lot of data coming out of it, and you have all seen New York University, former Assistant Secretary Steve Koonin standing up this Center for Urban Science and Progress, looking at New York City. Chicago has another big data center, they're looking at Chicago. Today, University of Glasgow is announcing they have the newest and the largest grant ever given to anybody, $20 million for looking at cities and data in the UK and social sciences. IIT Mumbai has one, so we are looking at all this. So, but is big cities the only thing that we should be worrying about, right? So here is the heart of the press, and you may have already seen this, that shows the data, the Jones and Cavan paper in Environmental Science and Technology that says that what we are trying to do in this American suburbia is actually wiping off all the benefits we are getting from the big urban areas because of this travel. We are traveling, driving so much in the suburbia that even if there is a lot of people living in these big cities, it's not making any impact. In fact, it's actually going backwards, right? Here's the other challenge that I think is, other than just suburbia, right? I just recently learned this. Jackson County in North Georgia, and if you can look at it, it's just outside Atlanta. It's growing so fast that right now in 2012, they had about little over 60,000 people. The moment they hit 100,000, they will have to be putting in a stormwater system by EPA. And that's mandated by EPA. So they need one answer. How much concrete and asphalt do I have that I can tax so I can make this infrastructure sustainable, the stormwater infrastructure sustainable? For people like me, it's a very easy answer. Oh, take a satellite image and extract all the impervious surfaces and you're done. Think about Jackson County, the people who are working at Jackson County, how far they are from that kinds of data and science and technology. So as a national lab, I think we have to touch, because we support the federal mission, not just cities, but everybody out there. So the big city approach is not scalable. We cannot scale the big city approach. So I firmly believe that if we have to go down this path, we have to look at our unique capabilities. Where are we strong at? The domain sciences that we do well, and then think about how we can impact every taxpayer and not just think about how I can make Atlanta better. I do want to make Atlanta better, but don't get me wrong. But when you go and talk to your sponsors, program sponsors, have you ever heard them saying, you know, DOE has this program only for Chicago and New York and LA? Right? It has to be touching everybody. So urban science and informatics, if you look at what people are trying to do, is one of the things is, you know, we want to be able to use lots of data and modeling and simulation to understand, as we are growing this future, we do not have enough capability of making, you know, setting up something and saying, oops, didn't work, let's, you know, this is not Legoland, okay? It is not Legoland where you can dismantle things and rebuild again. You know, if you pour concrete, it's an irreversible process. And the other thing is, it's not just the data that's coming from the infrastructure. It's not what the cars and the trucks and all those sensors data that you're collecting is the users. And that's where things become interesting, is that how do I know the intent of the users? How do people want to use something? What do they like? What do they do not like? And how can I optimize on those things? And again, you know, cyber data and computational infrastructures are very important. And I will keep repeating these three words. If we have to be successful in making data work for us in the infrastructure, there are three things that needs to work. One is we have to be able to monitor. Second thing is we have to be able to measure. And third thing is we have to be able to evaluate. We do not know what really we need to measure when we go out there, right? And then we have to build all these different capabilities that we want to go across the scale. I found this interesting example of unforeseen consequences. So the last 5 years, people dropping off pets in the area of San Francisco has gone up 42% because of the economic stress. And because of the economic incentive and smartphones, the subscription to newsprint newspaper has gone down so bad that it has essentially crashing the pet shelters because they don't have any more newspapers. So they are really struggling to get donations. Okay? When people really pushed for that, they didn't really realize what is the unforeseen consequences of your actions of pushing smartphones and pushing digital versions of your newspaper, right? So they didn't even know that where the manifestation is going to be like. And you know, there are many more examples of like that. Mapping is pretty cool, right? You want to know something about something. So if you go to the Atlantic, you know, they're saying, okay, if you map the iPhone users, you know a lot about people. Because, you know, in sustainability, one of the things is we want to know where people are and what kind of people they are. So here is Atlanta. So the reds are iPhones and the greens are Androids. Okay? And this is mapped out of Twitter feed. Okay? This is Chicago. This is LA. No, not LA. This is Houston. This is LA. This is good. I was afraid that, I have to tell you that. And this is Washington, D.C. Do you see a pattern? Why is that? And they're basically saying that, where the rich, where the rich are using this data, because iPhone costs a whole lot more. I don't know whether you can say where they live, but, at least it shows you that, there is a distinct pattern in there, and I have not looked at how they have done it. But here's an interesting thing. This is Android and BlackBerry. You know where this is? It's Jakarta, Indonesia. So what happened to iPhones? Do they not have rich people? So it's fascinating, right? So it's what can data tell me about a place that I can use for looking into different kinds of things. So I have to give you, at least one, because all these people make me look good and they do fantastic work. So I have to give you this example that I think I've been carrying with me as a flagship for what a national lab should stand for. So for those of you who do not know, we at Oak Ridge National Laboratory, we produce a number of critical infrastructure data sets for the nation. So when you go to national map and you touch that railway network that's coming out of here, or the schools network that's coming out of here, right? So the unique things that we have done, and you can talk to Nagendra about it, is the daycare centers. 9% of our future workforce this is what he told me. 9% of our future workforce right now is at a daycare center. Okay? We did not have a database. So he found 50 different data sets from 50 different states and put together a data set. But what I think is unique is I'm going to talk about these mobile home parks. The nation has a database which has 26,000 points, but that was not good enough. And in the emergency response community, everybody wants to know where the mobile home parks are because their nicknames are tornado magnets, right? That's where it goes. So, Anil, Harini, and these guys, they figured out a way of looking at saying, if picture is so what the business we are in is if a picture is 1,000 words, our job is to find those 1,000 words. And what they did is saying, okay, if I know how a mobile home park looks like, I can probably go and find it. And they started doing it. And they picked up this data set that is collected by the Department of Agriculture. 1 meter resolution, national aerial images that nobody uses other than pictures. So they are mining right now, mining that data, 9.8 trillion pixels. And this is fascinating that just for the state of Texas, 3 people tried to find it on their own and came up with about 1,500 points, and the automated detection got even close to like 15,000. If you scale it back like 1/3 of it, it's a significant progress, and you didn't have to worry about it. It happened magically, right? So data collected by Department of Agriculture, serving the rest of the federal community with this one data set. But here is the interesting thing. Who is the biggest beneficiary of this work? I'll go back to census. Census Bureau. 2000 census cost us about $15 per head. 2010 was about $40-some per head. At that rate, the nation is not going to be able to afford the next census. The Census Bureau spends enormous amount of money paying people who drive around and finds these mobile home parks. So we brought them a magic bullet, silver bullet, right, that changed their world. So now they are coming in saying, what else can you help us find? How else can you do it, right? Here's another example of, the biomass, which we have been working with our colleagues on the other end of the campus saying, this is our food, this is our energy. How do I know what's going on with my food and energy infrastructure, right? Again, I cannot just look at one spot. So, Raju has been working on this saying, one Modi style is about 23 million locations, 161 time steps. It's a one-time series, and about 460 of these cover the world every day, okay? And it was taking 11.5 hours to process that one tile for the time series. And with Experimenting with emerging architectures, what he has done, he has brought that down to 34 seconds. Okay? If we go and brag about our computing, that's what we should be bragging about. Nobody else is doing it. So we are very good at handling volume. I'll tell you that. I like this effort because we have done this for DOE, this bioenergy KDF work that you know. But the fundamental one database in there is this billion-ton update that Bob Perlak and colleagues worked. It's the foundational stone that helps that entire community do it. The state of the art was that every time they needed a scenario-driven output of a map, it would be a chain of commands that would come down, and Bob will look at his database and create a map and send it back. And then 2 hours later, DOE will come back and say, okay, I want to change the $60 per bushel to $58 per bushel, and the process repeats, right? What we did is we took that entire database and the application and we virtualized it. It's a database with about 70-some million records, right? It's not a big database that people are concerned about. But the science has to work for an individual researcher. An individual researcher is never going to download a 75 million records database and try to work on it. And that's where we need to come and do it. I don't know if you have followed this or not. There is this new company that has gotten new money and that are saying they now can take all kinds of data from the grid. And I found these things fascinating, the words they use. We use the petabytes of data generated by smart meters to create forward-looking model of the grid, similar to how supercomputers predict the weather. Okay? This is called OpenADR, and this is the company AutoGrid. They have made that claim out there. So here's our challenge. I was thinking that we are the experts on the electric grid and the data. And they're saying they've already done it. So what is that thing that we have to do that sets us apart? Talking about it, we have been working with our own backyard. This is Knoxville Utilities Board, and FEMI has been closely working with them, and you're looking at residential electricity usage, and you are one of them, very likely. Okay, this is if you pay KUB for your electricity, you are one of those dots going up and down. Okay, they have never looked at their data before. The only data that these utilities look at is billing. Are you paying or you're not? The energy usage data is they never try to look at that. Okay? So it was a mind-blowing experience for them just to look at their data. But that's not the point. We created this application. We said, now you can come and interact with your own data. You can see how much you have used over the months for the last X number of years, and you can benchmark yourself with your neighbors, your peers, anybody in the KUB footprint who has a similar home and age and size. It's fantastic stuff, right? It has still not gone out for people to use because KUB just doesn't feel that, it's something very sensitive. It's private. They will blow up. People will blow up. It's people like you. So I want you to start thinking, if this came out today and you are one of those data points, are you going to freak out? Because I'm going to get into that aspect very soon. Nothing we can do in this data game unless we get the buy-in from the people is going to work well, okay? Because we are protected by privacy. We know that few of us are responsible for the holes in our infrastructure. It's everywhere. You look at your freeway, it's those few people who are trying to zigzag and speed at 90 miles per hour, the relatives and cousins of James Bond. They are the ones creating the crashes and doing it, right? So this is a famous article in the New Yorker by Atul Gawande, who first pointed out in Camden, New Jersey, 1% of the patients accounted for a third of the city's medical cost. And what he found that 80% of those 1% lived in one single project, tall building. They had no education or very little education, very little information about how to stay healthy, and they all used the emergency room as their PCP. Every time they tried to work, they would fall down and get hurt, and they will go back. So essentially what they did is they said, we are going to fix that tail of the distribution where the challenge is and get the benefits. And, science has been talking about it. But here's the thing, we are all part of this prosumer generation, right? Or whether we accept it or not. We consume that data, but we are constantly producing, right? Everybody who is on social media, and you're tweeting, you're producing, you're adding stuff to this thing. It's changing the game for us because we have done science in always going to this instrument called survey. We send out surveys. We call people to do surveys. And they have abysmally low return rates. How many of you are immediately turn out that census survey that they send you at home? I don't know. Okay? So, the game is changing, but it's not changing that much. Crowdsourcing is a new term for data and people are going towards it. But think about the police hotline and the tip line and even Amber Alert, right? We never said crowdsourcing, I've known the tip line forever, but that's nothing but, so it's societally accepted phenomena. We know when it works for us, we are very willing to participate in it and provide very bad information. That's the big challenge that goes. But here is the challenge for the scientific community, okay? We are a civilization of averages. We love averages. Anytime you go and talk anywhere, it's the average consumption and the average spending, the national average, because everything goes back to, when I look at data, I want to know that whether I have an equal, that bell curve, that normal distribution of my population, right? But where the nervousness comes from is that now I am dealing with a data source where I do not know what that population looks like. I am only seeing a part of it. And that's all the time I have. So I don't know whether it's a bell curve or not. But can I make things work with that kind of an environment? And my colleagues in statistics get very nervous because they don't really can offer me a solution right now. Okay? But that's one of the key things issue other than credibility, privacy. So I'm going to zip through the rest of the things because Ramesh ate a lot of my time. So citizen science is basically, how people have been participating, how people like you and me participate in science projects. And Mookie Huckley, who has been, one of the leading authorities on this, he has come up with these great things. But I just read out on NOAA that, even our former presidents like FDR was a citizen scientist. He kept weather data, right? When you look at the TV news, you listen to the TV news and they say such and such from Oak Ridge reported X inches of rainfall. Those are all citizen scientists, right? They have a passion to be part of science. And it shows out more and more data that, regular citizens are very well qualified scientists. They may not be having, business card that endorses the fact. But as scientists, we are very snooty people. We don't like other people to come and claim they are scientists, So we resist them like anything. So what kind of things are people doing to improve science by providing their data? When Mookie first told me about this project, I didn't think it would ever fly because I was talking to the FAA program manager about the same problem in Chicago and some of our airports where people are complaining about the noise pollution. And the airports are now becoming part of the city. So in London, Heathrow, there are these citizens who are using their cell phones to record the noise as airplanes fly by. And then they're providing it back to the scientists for analysis. Going down to people who we do not think even knows about science, right? So there are these applications that have been generated on the smartphones where the people in the Congos, in Africa, they're reporting on their resources. How many trees is there illegal logging? Are there people killing gorillas and they have, they cannot read? So I saw the app and they have these icons and they click on an icon saying, I saw a tent, I saw a gun, I saw fire, I saw, dead animals, right? So my first question was, okay, that sounds pretty cool, but how the heck are they going to charge their phone in the middle of Congo, right? So little did I know that the Japanese have come up with this saucepan that you can now buy at REI, that if you boil water for an hour and a half, it can charge your phone in that time. Right? So data is not a problem anymore. NOAA has a page now for citizen science. Okay? They're claiming that they have 60 different projects that involve citizens. USGS has been playing with citizens and data provided by citizens for a while, but this is what I found to be extremely intriguing, how they're using Twitter for doing science and doing operations. If you look at that map, that's an earthquake that happened in Maine. What that radius is, the red radius, the red circle, is how far the S wave traveled after the earthquake happened, right? The sensors detected the sensors, right? And if you see anything blue, that means those people knew from Twitter that there has been an earthquake. So people outside that red circle knew from Twitter there has been an earthquake before the seismograms even detected it, by people sending tweets from where they have already felt it. I think that is fantastic. That is just incredible, right? I always question this fact that what do you do in 30 seconds? You have this, cool, sexy papers that saying, I can, detect these things 30 seconds before my seismogram will do it. But I found out that apparently the Japanese is what we are trying to do is what the Japanese do. In those 30 seconds, you can lift up every door of your fire station, stop the elevator at the nearest floor, and stop the high-speed trains. That's good enough time. Now that's fantastic progress if we can do that. Let me tell you a little bit about this people movement thing, because we are famous for creating this landscan population database, but anytime something happens, the database is obsolete, right? Because people have moved for whatever reason. So we have been trying to understand, what can you tell about people moving? And there is this famous real-time Rome, MIT, labs they came up with showing, from how the crowd followed the World Cup winning team from the airport to the city center by just tracking cell phone signals, right? And that's where a big problem comes, because we cannot really touch the cell phone signals. Social networking and disclosure, we are all familiar with the, checking. We are telling people or telling somebody that where we are at what time and what we are trying to do. Google tried this latitude and, they said, oh, we don't like it anymore. We will back it up. But it just kept growing. There are so many different things that tells, shows that where we are, what we do. Remember, that kind of data is fundamental for me to understand how people are using our infrastructure. Where they are, what they are doing, it tells me how they are putting pressure on my infrastructure. So it's a non-trivial data source for me. So several years back, I threw out this, at a meeting, and I threw out this thing like, what if this becomes a service? I subscribe to this service, I pay some money in exchange for some service that they will help me if something happens, if I tell them where I am, right? I do that. So that's the model. And I came up with these kind of things saying, there are lots of challenges with this. It's just not going to work. It just sounds, it's privacy plus what's the guarantee? But little did I know that there are these apps that are now flourishing with Life 360, Siren, GPS. And what that does is that this was incredibly successful after the Boston Marathon bombing, because it's a small piece of data that went out and told their families that they were okay. So it's immensely successful. Okay, I'm going to get into the social issues, because this is very important for us to understand. We always try to look at these things from where we are and our immediate environment, right? We all heard about, the Arab Spring and how things were going to be tweeted and, the next revolution. The London riots, when, the law enforcement were using, they realized that they were blocking the tweeters, and they realized that they were moving to BlackBerry Messenger, right? So it's almost like a parallel game. And I always think, I've been part of these kind of discussions where people say, oh, in Iran, they are blocking the citizens from, expressing themselves, and they're sending, and nobody can send out tweets in China. So this is what my awakening moment was when I was personally in India, okay? And there was this unrest going on. In one part of the northeast part of the country, there was an incident where people from the south had been exposed to some violence, and this rumor started spreading that the rest of the places in the south, the people from the northeast where the violence has happened, they will be attacked. Okay? So the government had to put these special trains to get people out from the south over back to their home areas, right? And that's one of those pictures of one of the 3 special trains that ran that day. The thing is, I've been sending texts to my friends and no answer, and I called them saying, why do you not answer my text? And they said, what text? And I said, I've been sending all these texts. They said, no, I didn't get any. I said, why? They said, oh, you don't know that 5 text limit? And I said, what 5 text limit? He said, well, the government has decided that you can only send 5 texts today, because that's the only way you can break that cycle of rumor spreading, because it was spreading through SMS, text messages. It's the exact same scientific model what we use to break the flu cycle when we stop kids from going to school. We break that cycle. Okay? It's the exact same model of spread. So, but here I'm thinking, okay, is that a good thing or is it a bad thing? All right? Empowering the individual citizen, again, it's an old story. This boy in Australia, he's 24-year-old. He was, adopted from eastern part of India, used Google Earth to find his mother after like 20 years by just looking at things, and he backtracked his route. He remember he was on a train for 14 hours, and he remembered where he grew up, there was a waterfall. And he knew where he was picked up from, so he took the train route and calculated 14 hours, where will he go, and started looking on Google Earth and found that waterfall and the village and went there and found his mother. It's a fantastic example of how big data empowers individual citizens. But I have to give you my example, right? So I'm in India, I get this email, drinking coffee in the morning saying, your credit card has been done something, frauds, call us, we have stopped it. So from being a national lab, what is the first thing I do? Delete. It's a phishing exercise. Delete it, right? Then I said, maybe I should log in and check. I log in and says, in red says, no, it stopped. So I called them, and they said, we would like to verify some of your charges, and I said, okay, $1 to Google. I'm like, I haven't done anything, but you check out these days, and they say, would you like to donate $1 to like the Children's Hospital or like Google Fund? I said, my wife is on the other side of the world, so I don't know what's going on there, so maybe she has done it. Then she said, $141.45 to Verizon Wireless. And I said, yes, I know that number because it comes every month, right? And then the guy says, $29.95 to a Christian dating site. And that got me nervous. I said, look, I can tell you I have not done it. But my wife, I think, has not done it. And I said, can you tell me what time this happened? And he said, at 2:52 p.m. in the afternoon. And I said, look, I know that would be very challenging because at that time, she posted this picture of her and the boys from Regal Cinemas. She was watching a movie. They were watching a movie. And the guy said she would be right because at 2:58, we declined her charge from Regal Cinemas in Turkey Creek. I felt empowered from across the world. Okay? I think that's what big data should do for me. Social media and big data should do for me. So here is where I'm going to go in a completely different tangent and challenge your thought process. We do all these things. What is our optimal need for energy? Energy, how much energy do we need to survive? How much food do we need to survive? My question is, do we know how much information do we need to survive? What is our biggest challenge for the nation in terms of food and energy? Obesity. Is there an equivalent of obesity if we get too much information? Can that have an impact? I don't know. I'm just asking. These are things that I think are hard questions that I haven't been able to answer. Here's one thing we need to all watch out for. The power of big data exists in the private sector. Government is opening up its data. Private sector is not. In fact, private sector is creating data. Like Google is going out to countries, sponsoring these mapathons. There are thousands of kids who are mapping and getting all this infrastructure data that belongs to the private sector better than what their local government has. So there was a big feud between the government of India and Google. I thought that it's not a level playing field anymore because, the apps world, what they did is they said, we are going to open up all these streams, you can design an application, and that unlocked the power to anybody. Like a high school student can become millionaire by designing an app. But here is where I think we are being left behind. I saw this in 2009 in India, where what they have done is they have created this application that has virtualized the agricultural extension service. So these farmers can take a picture and record a question, and then they send it somewhere, and then they get an answer back saying, your potatoes are cracking because you probably have this, and you need to apply this kind of fertilizer. The question was not what the farmer is getting. It's free. The question is, imagine the kinds of informatics, the data that company is generating, that space-time on food and crop and agricultural health. Okay? That's a gold mine. That's a gold mine, but it doesn't exist in our world. So what do? My thought is that we will all become, as citizens, we will all become part of this, what I call open data economy. Okay? We are all players here. It's a new sharing paradigm. We think privacy is a concern, and I can have these discussions with you. But I will tell you one thing. What I think is the way to overcome this is that you turn that privacy issue on its head. Privacy is mine, so is my data. I can tell you my social security number and my date of birth. You can't stop me from it. So the question is, how do I get people to share that data voluntarily, right? Sharing is an interesting aspect. In fact, when Google VP was here, we were talking about transportation. We said, the future transportation is where you do not know what is public transportation versus what is private. So you are coming out, you broadcast a message saying, I'm at 4,500 knot, I want to go to 1505, and within 30 seconds, somebody pulls over and gives you a ride over there. They have received it. So we are optimizing the space, the energy, the efficiency, everything at the same time. Right? I know what you're thinking. You're thinking, how do I know that whoever is stopping, how do I get into his car? Do I know that person? Do I trust that person? Which is an important thing, right? But it's all motivation and the key. Airbnb. They are renting 150,000 beds a night across the world. These are people like you and me who have enlisted. You are insured up to $1 million. They will come, take the pictures, and put it up there. And all you are doing is you are basically saying, I'm an empty nester. I have this 5,000 square feet house with nobody uses the 3 rooms. I will put it up for rent. It is driving the hotel industry mad. Intercontinental rents 100 million nights a year. 100 million bed nights a year, Intercontinental. Airbnb did 55 million last year. Okay? So these are people who do not know. They're just, they're just hooking up. I have a nephew who has done 40 countries in 9 months doing what they call couch surfing. So you sign up, and all you do is make a commitment saying, when somebody comes up through your town, you will offer them your couch in the living room. He's traveled 40 countries in 9 months. So sharing is becoming an important aspect. We are putting out a lot of data. How many people have one of those things, Kroger and Bilo and these grocery store cards, right? Why are you doing it? Do you scan it? Why are you doing it? They know what you're buying because you are incentivized that you are getting that discount, right? So I always thought that, maybe that's the reason everybody does it. But then I read that actually the cool killer app is that when they come on TV and say, you should not drink or you should not eat this peanut butter because it's contaminated, and they read out a 14-digit batch number. And I'm scrambling in my cupboard trying to find that batch number and trying to match it, right? What they will do is they will send you a push alert saying, we know you have bought one. I will gladly carry that card if I get that service. I'm fine if they know I eat chicken. Or I don't eat chicken, whatever it might be, right? So, unfortunately, it got bigger. This reusable grocery bags. You think that economic incentive is the one that works, right? So they did a survey, and I apologize that it went in the back, but I'll tell you. When they did a survey of people saying, how many of you are willing to buy a reusable grocery bag? 71% said they would. Why? You are spending money. Why would you want to spend money when you can get it for free? Right? Because they're motivated by a cause. They're trying to be responsible for a cause. Just like we are all committed to sustainability. Right? That's why you are here. You want sustainability. I want sustainability. But I'll tell you, I cheat. When I go to my health club, I'm circling around to find the closest parking spot. And how many other people do that? So the question is, how do I exploit that incentive from them? That they will, if I tell them that, look, if you shared all these different kinds of data about your life and what you do, I can make science better. I would say, if 25% of the 71% shared their data, we will make tremendous progress in science. So I want to be part of this. I want to get my 2 cents. There's a company called Polk that basically takes your VIN numbers. They buy the data in bulk from the BMV. They aggregate the data, they clean it up, and then they license it to you for enormous amount of money. You want my VIN data, I'll give it to you. I have no secrecy about the car I drive. I don't know how I can. I don't know how I can be secretive about the car I'm driving. I will tell you my VIN data, right? So I want to be part of this, but how do I become part of this? How do I get in there? This is the medical thing, I go somewhere and I want access, I want to carry all my things. I go to a foreign country and I have a sinus infection, I go there and they say, yes, this is my dad's friend who would ask me, so do you take any regular medication? And I said, yes. He said, what is it? I said, Allegra. And he said, okay, what is the chemical composition? Because nobody has ever heard about Allegra. Right? I said, I have no idea what the chemical composition is, and I'm a scientist. And I said, okay, can you tell me what is the dosage? How many milligrams? And I said, it's D. Right? And then I come up with this deep wisdom and knowledge about my medicine. That is, I say, it's white and it's round. Right? I don't have a way to carry that information of all the data that you and I producing that somebody else is making money off. Okay, I want to be doing that. So crowdsourcing is working just fine, except we are all going to become part of this. You all see how the media is making a phenomenal effect of this. USGS did another program that was phenomenal called Netquakes. They sent these instruments and they asked, are there people who could volunteer to put one of these in their property? They were looking for like 1,400 or 2,000, and they got 14,000 volunteers across the world because people were just curious. Oh, I want a seismogram on my property. You know where the cost savings came? When it was not working, they didn't have to worry about it. Those people will call and say it is, and they did not have to negotiate the right for that land. Okay? So participation by citizens is making things incredibly. There are social things that, crowd fatigue, things of people that, are you going to be tired of contributing towards science? Just like you get tired of donating money. So I will not go into the details, but there are social, legal, ethical things are there that if you're telling people that, turn on your GPS, are you telling them that you are going to be running out of battery faster than usual because now you have your GPS turned on? We do not know what legal limits are because this is so new. And this is one of my summer interns from 2 years back, Eric Young. He sent me these pictures after Sandy. His house is in the Pennsylvania coast. And he said, look, this is what I collected. We have no national strategy for curating this data. This is a gold mine for doing a lot of kinds of science. The federal government do not want to touch it because of the PII issue. I think as a national lab, that's one of our goals, is to find out how we can contribute towards holding and doing this data. So I told Teresa when she twisted my arm to do this, and she made me a condition that I will tell at least one Jesus joke. Okay? So that's my condition, so I have to do it. It's not like I want to, but that's for the shortage of time. Here is something we are all worried about, right? Texting and driving. And I think 400,000 crashes attributed, 300,000 deaths just in 2012. How many people are now you are aware that AT&T, Verizon, and Sprint have apps, free apps that you can download that will disable your texting capability when your speed goes beyond 10 miles per hour or 25 miles per hour? How many people have it on their phone? You are all related to James Bond. You have no fear, right? So it is an incredible thing. Why are we not aware of this thing? Safety and saving lives is our biggest metric for our transportation infrastructure. Okay? So how do we get there? What do we do? So, I'm guilty. I didn't know, you must have seen that I did not raise my hand because, but I should. Now I'm having teenagers. So here is the best bumper sticker I saw. Honk if you love Jesus, text if you want to meet him. That's my Jesus joke. It's true. All right, so there is no shortage, and I'm not saying that I'm being comprehensive and all that stuff, but I have been very motivated about one statement that I read for this guy. Enrique Penalosa. He's a former mayor of Bogota, Colombia. He made a statement that resonated with me. It moved me. It impacted me. He said, the sign of a developed country is not where the poor have cars. It's where the rich take public transportation. My kids were very puzzled with this statement, saying, what? So I'll leave it there, okay? And I know that I have wasted more than your hour. And I don't know if we have time to do things, but I'll be happy to waste more of your time. Thank you. Thank you. Jack, you have a question.
I was at a climate conference this past week, and one of the big issues was focused on we all buy homes, and it's the biggest thing we ever buy in our lives. And we buy it without the equivalent of the EPA gas mileage sign on the side of a car. So you have some sense of the efficiency, energy efficiency of that car. Do you think we can apply some of this to create that for our homes?
Yes. That's a great question. Actually, with Connect, we did that. And Femi can show you that what we did is basically you could compare subdivisions. So when you are trying to buy 2 homes and you're looking at 3 different options, you are basically looking at the similar type of homes. And you could compare that, benchmark it to see which one was more energy efficient than the other one. I don't know how you would do that with new homes, because it doesn't have any performance data. But with used homes, the older homes, you could do that. Yes, it's already there. In fact, the City of Oak Ridge manager wants to do that to bring up the standard for energy efficiency for all the renters who receive federal subsidies, because there are, I don't know how many hundreds of homes there apparently, And these people rent it to the lowest socioeconomic class, those homes, who can barely pay rent. And those are the most energy efficient, inefficient homes. And he thinks that nationwide, it's tens of billions of dollars that we are bleeding on that. Paul.
Thanks very much. Really interesting. I have a concern.
One?
Because this is so exciting,
yeah.
It's also so popular, everybody's getting into it.
Mm-hmm.
Kaggle is a website that claims it's the globally premier predictive analytics and data science website. They run continuous contests for people who are interested. They have 100,000 people who identify themselves as data scientists.
Mm-hmm.
In the space of like a month. That many people said, this is what I want to do. How do we ride this wave appropriately, and how do we differentiate ourselves from huge volumes of people getting involved?
Great question, and this brings me to, as I said, that when I was asked, can we do this? Why should we try to do it as a federal national laboratory? I made it very clear that we cannot. So if we go out, the action right now is in the transactional data space, which we have no control over. Okay? The private sector is making a killing by going into the transactional data space. And I was brutal enough to remind people that when our own lab decided to run the data analytics to see efficiency, bring efficiency into our printer space, and I don't know, Becky, when it's getting rolled out, but now we are going to have streamlined printer, how much printer we can do. I don't know which lab data scientist participated in that exercise. Did we have any? I don't think so, right? We cannot compete in that space. So that's why I went to that thing is that, what do we do well? We are very good at looking at the volume issue because we have some of the biggest data generators, like the big computers, the big instruments, and we have the associated domain science strength to bring justice, right? So we do very good in climate. We are doing excellent in sort of the spatial satellite images, those kind of data processing. You look at a DAC, you look at ARM, but it's founded in our science, right? The other thing is academia or industry, they're looking for that blip. So once you publish those two cool papers, the attention level goes down, nobody wants to do it, right? I give the example of Landscan as one of those things, that there is no way you can publish 2 papers every year from Landscan. It's just not possible. But should we leave it because we cannot publish anymore? It's because we are a national lab, we are supporting mission, we have made that commitment to have that continuity in support, right? So that's why I said for this to become integral to the governance process, where the federal government will have programs that will make use of these kind of data features and things like that, we have to be there to measure and evaluate whether that's sustainable and not. I don't think private sector is interested in doing that. They're just coming in saying, I will make you more efficient, tell me your business data, right? They do not have the science background. So that's our niche. I want to show where the ROI is for science. Let's take climate, right? Any kinds of physical modeling that you are doing needs some level of field validation. And if that involves going out there and seeing, whether some flowers have bloomed or the bees are flying, collecting that data is the most expensive part. But are we looking at this other data universe to understand, can I get that same data value add that now BER can look at it and say, look, we don't really need to worry about it. We can use that data sustainably, and we have confidence on that. We know that it works for our science, and we will make it go forward. Nobody else is doing it. That's our job. Okay? That's where we would excel. We will not do hackathons. We are not designed to compete in hackathons. Okay? Find the electric bulb or find the cab. We won't be able to do it. If we go after that, it's going to be I don't think it's a productive path. Thank you. Thank you. This was great.